Alright, AP Calculus, we are here, 2-1. Oh, I forgot to print out the unit guide for you. But here's the unit guide. Notice that there are 10 lessons in our unit guide. There are another 4 self-checks, then pre-test and fix-up and test. But yeah, everything in this unit is derivatives. So we're starting on basic, and then we're going to do more advanced. So today's date is Monday, September 9th. Let me bring up my pen here. Monday, September 19. All right. Make sure your name and date are on the paper. Okay, by the way, I did these notes like 5 minutes before you got here, so that's why it looks kind of normal, but I forgot to do objective and a few other things. The objective today is to be able to take, so students will be able to take basic derivatives of polynomials. Bless you. Bless you. But you don't even know how to take a derivative. Before we even do that, I need to make sure that you know how to simplify negative powers and square roots, because in calculus, and Arrow will nod her head in agreement, we hate negative powers and we hate square roots. We hate them. We hate them. If you ever see negative power or square root, get rid of it immediately, unless you're doing those shortcuts because you're so fast. But for our first little baby step, get rid of them. X to the power of 4. I don't like negative 4. How can I get rid of that? Shout it out.
1 over x to the 4.
There it is. 1 over x to the power of 4. Perfect. We flip it and then change the power to a positive. Hey, it's positive. We're okay with that. All right. We don't like, well, actually, I might have to amend that statement later as to we don't like negative exponents. But for now, for this lesson, we're not going to like them. How do I simplify this one, Gio?
3x. X to the power of 3.
There it is. X to the power of 3 over 1, or just x to the power of 3. Perfect. Ooh, who wants to try the harder one? It's between Stego and Arrow.
I'll try.
Go for it.
Is it 1 over 2x to the 8?
You are so close. X to the power of 8 is correct, but the 2 stays on top. Yeah. So, and because most students will make that mistake, is the general line of advice. Most people will bring that 2 down with the x to the power of 8. To switch the exponent from a negative to a positive, you only move not the coefficient, but the variable. So by saying variable, not the coefficient.
Mr. Sindel, is this one of those things that, like, you're going to tell us this is how it is now, but then later you're going to be like, no, that was a lie. It's actually different.
This will never be a lie. If you ever want to switch a negative to a positive for an exponent, you only move the variable. The one thing that is kind of a lie is we don't like negative powers. They're okay sometimes. It helps us avoid the quotient rule, which we don't like. But they're okay. You can use power rule on negative powers. It's okay. All right. So far, so good. We remember how to do this all the way back from Algebra 2 and reviewed in pre-calculus and reviewed again in AP Calculus?
Yes, sir.
All right. Let's go square roots. How do I get rid of the square root and treat this as a power? Claire, go.
X to the 1/2.
It is indeed x to the power of 1/2. The reason that this is x to the 1/2 is because this x on the inside of the square root is to the power of 1. And by default, square root means it has an index of 2. 1 divided by 2. So, let's see if we can apply that rule to the cube root of b using fractional exponents. This is b to the what power? Someone aside from Claire. Stego. It is indeed 1/3 because b is to the power of 1, index of 3, 1 divided by 3, 1/3. Between Geo and Arrow, the 4th root of x to the power of 3 is x to the power of what fraction? It is indeed 3/4. All right, we're all good on how to get rid of square roots to turn it, or get rid of the radical symbol in order to make it into a fractional power. All right, so let's talk about vocab. Derivative notation. How do we pronounce these things? So I read this as f prime of x. That's what you will say every time that you see this. F prime of x.
What do those quotations? Oh, no, really.
That means like how I say it, yeah.
Yeah, I thought I only saw the right side. I didn't see the left side. I was like,
Oh, yes, that would mean something very different in calculus. And then how do I read this one? D dx. You don't say d dx, you say derivative. of, and then we'll say that square is of the blank, of blank with respect to x. And we'll be talking about that over and over again, so we'll get used to it. But like kindergartners, we're all going to rehearse this. I should put quotes around this. Like kindergartners, we're all going to say the same thing. So you guys are going to say f prime of x after me. 1, 2, 3.
F prime of x.
Good, all right. And then we're going to say derivative of, and we'll pronounce this blank. Derivative of blank with respect to x. 1, 2, 3.
Derivative of blank with respect to x.
Again, 1, 2, 3.
Derivative of blank with respect to x.
There it is. All right, so who wants to volunteer to read the problem right here?
Derivative of 5 with respect to x.
There it is. Derivative of, okay, someone else. Read this one.
Derivative of negative 2 with respect of x.
With respect to x, yeah, good. And then, Claire?
Derivative of k with respect to x.
There it is. And then we will eventually, especially when we're in BC calculus, this will no longer be x. It'll be derivative of something with respect to t, with respect to y, with respect to capital W. These will change, but for, bless you, bless you, bless you. But for the most part of, well, for the entire part of this unit, we should be dealing with respect to x. That won't really change. It will get harder, I promise. All right, so who knows what the derivative of 5 is with respect to x? Claire.
1.
Arrow.
0.
It is 0.
What?
Woohoo!
What?
I know it doesn't make any sense.
The derivative of negative 2 with respect to x is?
0.
It is 0. Let's assume that k represents a constant. Obviously, you spelled constant with a
it's
k.
1. No, it's not 1. I have no idea.
0.
It's 0. Woohoo! Oh man, those are easy.
Why
Derivative of
though?
constants are
Why
easy
though?
peasy,
Not though.
lemon squeezy.
Why though?
Oh, I love the y
I don't
question.
even remember.
And because it's an AP class, I can't really get into it too much until we hit the backside of the notes, then it'll make a little bit more sense. But yeah, for now we're just going to memorize the rule and then hopefully delve into the why in the future. And that is the difference between an AP class and a non-AP class. If it was a non-AP class, I'd be like, put on the brakes, hold on. We need to answer the why because that is the most important question in mathematics because it's an AP class. I kind of need to rush through it and then hopefully it'll make sense out of it by the end of the lesson.
Teaches me the exact opposite.
Yeah.
Always
know.
need to ask why.
Not
I know. I feel bad.
Not sensible.
Every time that you guys get mad at that, it makes me feel guilty because I want to tell you the why. It's just an AP class. I'm sorry. If you have time at lunch or after school, I will go into hours onto why. But in general, the derivative of a constant is
0.
0. There it is.
Yay.
Just memorize. The derivative of a constant is 0 for now. Linear rule. All right. Who wants to take a stab at this? Oh, first we need to read them. Who can read this one?
Derivative of 3x with respect to x.
Yeah, let's all read this one. Everyone at the same time. 1, 2, 3.
Derivative of negative 2x with respect to x.
Good. Ooh. Okay. I think you guys know how to pronounce these. Okay. So who wants to do derivative of 3x with respect to
one.
x?
3.
3.
It's 3.
Okay, that's
Ooh. Let's see if you can find the pattern. Let's see if you can find the.
Negative
Oh, negative 2. Ooh. What about this one?
12 plus 1.
No, just 12.
12.
12 plus 0.
It's 12 plus 0 is actually the answer.
What?
That's the one from the other bit with the. Okay.
Oh, I get it.
It's
Okay.
12 plus. My plus got
But
hidden.
to write it
Plus
correctly, do you
0.
have to include the plus 0?
No, you do not. I'm writing that because it makes
more
sense. But the answer is 12. And then derivative of box x is
Box.
box. Yeah, there it is. There's the linear rule. Just take the coefficient. So far, so good?
Whoa.
Oh, we're doing calculus. This is easy. You don't know why it works, but you know how to do it.
And now we go to the backside.
And now we're on to the backside. Simple power rule. So this is finally getting a little bit harder now. I wonder if anyone can remember this.
It's n.
No.
You're so close.
It's n times 1.
It's n to
It's
the
one
x
n.
to the
It's 1 to the power of n.
It's n to the power of 1.
This is going to be not n to the power of 1. It's going to be n
Wait.
x to the power of
N minus
One.
1.
n minus 1.
Huh.
Ooh.
Oh, I remember this.
Ooh, that's a little bit difficult. So we need a lot of examples for this one. I need like 6 examples, and at least 5. I know because I ran out of time. You guys came in here. I'm like, print, Stego, grab it. I'll get this together. Yes, so I'm going to do at least 5 examples here, and I'm going to add to the notes for next year. So, first example, The derivative of x to the power of 5 with respect to x is... Who wants to try using this formula? So the formula states...
5x to the fourth.
Oh, you guys are too good at this already. 5x to the 4th. This rule states, bring this n down. Bring that n down to become a coefficient, and then subtract 1 from it. So this 5, we brought it down, it's now 5, and then subtract 1 from it, 4.
And if it has a number in front, the number in front doesn't matter, right?
The number in front will be multiplied by whatever you bring down in front. We'll see that in this third example.
So it's n times the whatever the heck that thing's called.
Right.
So technically, our definition on the top is wrong.
Yeah.
It is correct, but if I want to generalize that, you can have a generalized formula over here. You can say dx of ax to the power of n. Now we have some coefficient that we don't know, a.
Is equal to a n x to the n minus 1.
A times n, that's the coefficient, x to the power of n minus 1, exactly. You do multiply those coefficients. We'll see that down here in example 3. But before I do that, can either Gio or Stego do example number 2?
40x into 39 power.
Do you agree, Stego?
Yes.
It is indeed correct. Good job, guys. All right, now let's get a little bit more difficult. The derivative of 3x to the power of 7 with respect to x is...
21x to the power of 6.
Oh my god, you guys are killing it already. What is this? This is easy peasy lemon squeezy. Let's try a different notation here. Let's say I have some function f.
Uh-oh.
The function f of x is 2x to the power of 5.
And then the derivative is
How do I write the derivative?
1 over...
Oh, how do I say the derivative using your fancy notation right up here? Derivative notation. Yes, f prime of x. I say f prime of x, the derivative, therefore, is equal to... You can say it now, Claire.
1
What?
x to the 4th.
Where do you
Oh no, 10x to the... Sorry, 10x to the 4th.
You're good.
I spaced on this.
Good. So, I read this as f prime of x is 10x to the power of 4. Or the derivative of f is
So,
10x to the power of 4.
You multiply.
Oh!
So you multiply and then subtract 1 from the power.
Say again?
So basically, you're just multiplying it, like 5 times 2, and then you just subtract 1 from the power. That's it.
There it is. Let's try it one more. I said 5. This will be our 5th one. Let's say I have a function g of x. And let's just say that's equal to, I'm going to use some review. Square root of x. Let's see if you can do this one. Next challenge. I want you to find, and I'm going to write it down here because you're going to need some room, I think. What is g prime of x? I want to know this guy. Know him as my friend.
So is
Who can do him?
Is it x to the power of 1 half?
Something x to the power of 1 half. I'll write Gio's half. X to the power of
To the power of
negative 1 half.
But then,
But what about the
'cause it's
1 half?
negative
Oh,
1
you're saying, you're just, okay, sorry, Gio. I misinterpreted. This is indeed x to the power of 1 half. So what, therefore, is the derivative?
So you just make it negative.
Well, first you do what? First I do
You,
bring it down. So it's now going to be,
Get you.
I brought it down. 1 half x. Okay, now what do I do?
What? Wait, no, you already did that.
I subtract
What?
1. What's 1 half minus 1?
Negative 1.
Negative 1 half.
But it's weird. You're not allowed to have
I don't like negative exponents. I don't like them. How do I turn that into a positive exponent?
X squared, right?
Really?
This is now equal to
No?
You moved it down.
1 all over, that 2 is still in the denominator, and now the x is also in the denominator, and now the power is
Square root of x?
1 half. And if you want to go even further, you can say this is 1 over 2 radical x.
But you said we don't like radicals.
We don't like radicals, but sometimes the multiple choice answers, they put a radical in the denominator, and you have to be able to find that. The way that I would like this is right there. Stop right there. That's in my class where I like it.
So basically, it's just taking like the other equation to make so the yeah, I got you.
Exactly.
Yeah.
Got it,
Okay.
Gio.
Yeah, it makes sense.
Okay.
Questions? Don't do the summaries. Don't do the summaries yet. Wait until tonight because you need time to forget, to go down the curve of
No.
We
forgetting.
don't have time.
We don't have time to forget everything.
We'll forget for like
What time is it?
That concludes the notes.
Wait.